Hello everyone, welcome to the session. In the previous session, we'll see a translation problem for the kinetics, and in this session, we'll see rotation and general plane motion problems in kinetics. That means how to apply your kinetics principles to solve the problems. A homogeneous solid cylinder of weight 1,100 newtons, whose axis is horizontal, rotates about its axis in frictionless bearing under the action of the weight of 10 newtons block, which carried by a wrapped around the cylinder. What will be the angular velocity of the cylinder 2 seconds after the motion starts? Assume the diameter of the cylinder as 100 centimeters. So first we'll try to understand this by the figure. See, here we have a cylinder, a solid cylinder, so which is of weight 100 newtons, whose axis is horizontal and rotate about its axis in frictionless bearing under the action of the weight of 10 newtons. Okay, the 10 newtons is acting on this, which carried by a rope wrapped on it. So the rope is wrapped here around the cylinder, and what will be the angular velocity, that means omega, of the cylinder 2 seconds after the motion starts. Okay, after 2 seconds, what's your angular velocity? That means you can simply say what is your final velocity. Assume the diameter of the cylinder as 100 centimeters. Now we'll see the problem, how to solve this. Weight of your cylinder is 100 newtons. Mass of the cylinder is, by G you're going to get the mass, which is 10.194 kg, and the weight of the block is 100 newtons. And you can convert these into mass by G, which is 1.019 kg. Now first consider the motion of the block, and here we have the angular velocity minus the force which is acting, the effort or the force which is acting, and that equals to ma. Now see here, consider the motion of the block, which is weight minus effort, and that equals to ma. And now what is mass? It is 1.019. And what is area? This is your acceleration, right? So make this as equation 1. This is the motion of the block, that's it. Okay, which is the block we already seen, right? This is the motion of the block. And the next, consider the motion of the cylinder. Okay, for the motion of the cylinder, we have equation which is like P equals to IA divided by R square, where I equals to moment of inertia, which is mr square by 2. And now if you substitute this, okay, if you substitute this moment of inertia here, so what you're going to get, mr square by 2 into acceleration by r square, and this is the motion of the cylinder, and that equals to, which is substituting your mass, your r square gets cancelled, and this is your mass of the cylinder, and this is the acceleration by 2, and what you're going to get is 5.097 into a, this is your acceleration, and make it as equation 2, and this is your equation 1. And now from equation 1 and 2, if you solve those two equations, you're going to get the acceleration, which is 1.635. okay, and now we required is angular acceleration. Why? Because we required angular velocity here. Okay, for that sake we required the angular acceleration, which is acceleration divided by the radius of your cylinder. This is your acceleration 1.635, and the radius is 0.5. If you substitute this, you're going to get 3.27 radians per second. And the angular velocity what we required after 2 seconds, the time is given. So we have an equation to find the velocity, which is angular velocity is equals to initial angular velocity plus acceleration, which is angular acceleration into time. So initial velocity is 0, angular acceleration, which we find just now, which is like 3.27 into the time 2 seconds. We required the motion or angular velocity after 2 seconds. So finally what you're going to get, the angular velocity is 6.54 radians per second. This is the problem on rotation. Okay, and now we see the problem on general plane motion for kinetics. A solid cylinder and a sphere are started top of an inclined plane at the same time and both roll without slipping down the plane. If when the sphere reaches the bottom of the incline, the cylinder has the traveled distance 12 meters. That means when the sphere, we have two bodies, which is solid cylinder and the sphere. If the sphere reaches the ground of your like bottom of the inclined plane, the cylinder has traveled only the 12 meters. Then what is the length of your distance of the incline? We'll try to see the figure first. See, they're asking about the length of this distance of incline. Okay, and now on this we have a sphere and the solid cylinder too. Just assume this is the phase diagram of your both bodies, which is solid and the sphere, and the weight is acting downwards, which is mg, and this is the component of your mg, which is mg sine theta. And if you resolve it in this way, you are going to get mg cos theta. But what we require to find is the total length of the distance of the incline. Now we'll see the solution. Consider the motion of the cylinder. See here, first we'll see about the motion of the cylinder and later we'll see about the sphere. And now here the weight is acting downwards and the force is acting upwards for the cylinder, that equals to ma. And these suffix are nothing but for the cylinders. Okay, mass of the cylinder, force of the cylinder, mass of the cylinder, acceleration of the cylinder. And now the force into the distance or radius r is equals to I into this is alpha, I alpha. What is I? Moment of inertia, mr square by 2. What this is alpha, which is angular acceleration, r for the cylinder. And now if you bring this r to this side, so if you resolve that, r will get cancels, the square and the r will get cancels, and what you're going to get here is mass into radius divided by 2 into alpha, and that equals to, and this alpha you can write it as angular acceleration as linear acceleration divided by the radius, and that equals to, again if you cancel these two radiuses, and you're going to get mass into acceleration divided by 2, and make this as equation as 2, and this is as 1. And now after substituting the fc in equation 1, the equation 2 value in the equation 1, you're going to get this relation. And if you resolve it, okay, if you resolve it, you're going to get the acceleration, which is 2 by 3 g sine theta. Clear? Just replace the fc in equation 1. And now make this as equation 3, and the equation 3 gives the acceleration of the cylinder, and the acceleration of the sphere can be derived similarly, and its value is given like this. This is the acceleration of the sphere. You can solve in the similar way as cylinder. You are going to get 5 by 7 g into sine theta, and this is the acceleration for sphere, and this is the acceleration for cylinder. Now for the distance traveled by the cylinder, you can take this equation, which is s equals to ut plus half at square, from the equations of motions, and here the distance is traveled, which is like 12, okay, and the initial velocity is 0, and now you got the acceleration of the cylinder, right? Substitute here, which is acceleration of the cylinder, t square, make it as equation 4. And now if the s is the distance traveled by the sphere, and take the same equation of motion for a distance, and we don't know the distance for this, for the sphere, and we have to find the distance which is traveled by the sphere. Initial velocity is 0, and the acceleration of the sphere is 5 by 7 g sine theta and the t square. Okay, so once again, what actually we require? The distance which it traveled, right? Here the cylinder is, once see the question here, when the sphere reaches the bottom of the incline, the cylinder has traveled of distance 12 meters. So what is the total length of s? For the cylinder, he given the distance, which is like 12 meters. But when the sphere reaches the bottom of the incline, we don't know the distance. So that distance for the sphere we require. What? Now we'll see the distance for that sphere from the equations like 4 and 5. So from these equation 4 and 5, So we know the distance for the cylinder when we require the distance for the sphere, and from these equations, if you resolve these two equations, you are going to get the distance for the sphere, which is 12.85 meters, right? And the distance traveled by the sphere is 12.857 meters. Thank you.